Hello, welcome to today's lesson. This lesson is the second on our course manual for the semester. We are going to be looking at Chemistry 216 SW, that is Practical Organic Chemistry. Our lesson today is titled Identification Test for Alcohol and Phenols. I'll be your facilitator for the lesson. My name is AYK Ajiman. Thank you. Let's begin today's lesson. In this lesson, we're looking at how we can test for alcohols and phenols. As we go towards the end of the lesson, we'll look at such sample questions, or we test ourselves with some questions. As usual, I'll provide you with references to help you for further studying of the lesson or topic for today. Alcohol, it's very common around us now. Just by the mention of alcohol, our minds are tilted towards beverages, that is alcoholic beverages. But alcohols are very important in the sense that they can be used as solvents, drugs, and disinfectants. To our men, I'm sure you are familiar with that cold liquid that is applied at the edges of our hair when we go to the barbering shop for a haircut. That is an alcohol-based product used for the purposes of disinfecting our hair or our head against bacteria there may be after we have undergone shaving. Alcohol is an organic compound with a functional group known as hydroxyl functional group, represented in symbol form by OH. This OH is bonded to a carbon atom. Alcohols have the general formula CnH2n plus 1 OH, with the OH being the functional group. Now, there are some common examples of alcohols that we would be familiar with. Common ones like methanol, ethyl alcohol, 2-propanol, also known as rubbing alcohol. When we come to what phenols are, we are saying that phenols are molecules that would have the OH group attached to a ring. Here, the ring is supposed to be a benzene ring. In other words, phenols are a benzene ring that has OH attached to it. I hope you can remember that. Look at these structural examples. You'd realize that this compound has this as our benzene. This would be our OH functional group. So we have our benzene ring here and the functional group. This makes it a phenol. So we have other compounds where you can identify the OH functional group. the OH functional group can be identified in these examples. In the broad categorization of alcohols, we can say that alcohols can be aliphatic or aromatic. The difference here is that one of the categories has a benzene ring or OH attached to a benzene ring. The other do not have or contain a benzene ring. The alcohols with benzene ring attached to the OH or the OH attached to benzene rings are referred to as phenols, as we have already talked about. The ones without the benzene ring is termed or categorized as aliphatic alcohols. This has been treated in the theoretical aspects of this course. This overview is by way of trying to review our lessons in the theory aspects. As we have said in the previous slide, aliphatic alcohols has no benzene ring, but aliphatic alcohols can be grouped into three: primary, secondary, and tertiary alcohol. Now, the difference among the three, that is primary, secondary, and tertiary, depends on whether the carbon, or what we can term as alcohol carbon, is attached to either one, two, or three alkyl groups. When we look at the structure that we have here, the OH is bonded to this alcohol. How many alkyl groups are bonded to this alcohol? You realize that it is only one alkyl group. If it is only one, it means that that alcohol is a primary alcohol. Let's look at the carbon that has the OH bonded to it. How many alkyl groups are bonded to it? We have 1 and 2. That makes it a secondary alcohol. Now, based on how we have explained primary and then secondary alcohol, can you find a reason why this structure is termed as a tertiary alcohol? Yes. The first thing you do is to identify the carbon attached or to the OH functional group. How many alkyl groups are bonded to such carbon? We have 1, 2, and 3. Once there are 3 alkyl groups bonded to the carbon with the OH attached to it, we are saying such a compound is a tertiary alcohol. Now let us talk more about phenols. As we have already been exposed to, phenols are categorized under aromatic alcohols. They have the OH functional group that is bonded to the carbon. But this time around, the carbon exists in an aromatic ring. Now, we are saying that phenols are acidic than the normal aliphatic alcohols, and that they are very toxic when concentrated. Most of the uses of phenol derivatives can be seen in medicinal areas or aspects of our lives. Example is the use of thymol to kill fungi and hookworms. Now, we've already done the categorization of the alcohols. The test for alcohols, whether they are aliphatic or aromatic, determines which type of test that you will do. So looking at this flow chart, alcohol has been categorized into two: aliphatic, aromatic. For aliphatic alcohols, it undergoes two tests. One, chromic acid test or Lucas test. For aromatic alcohols, which is phenols, we are looking at ferric chloride tests and bromine water tests. In the next slide, we'll be looking at the various tests. Please stay tuned and then let us learn this together. Now let us look at the first test for testing aliphatic alcohols. This test is called the chromic acid test. Now, we are saying that the main reagent used is chromic acid. This acid is an oxidizing agent or reagent. This is used to convert alcohols to carbonyls and carboxylic acids through oxidization. This test is very important as it is able to distinguish, separate, or help you identify primary and secondary alcohols from tertiary alcohols. Reagents like acidified dichromate solution is used. When it is used, primary alcohols are oxidized to carboxylic acids, whilst the secondary alcohols are oxidized to ketones. Let us go over what we've just said. We are saying that in this kind of test, we are going to use acidified dichromate solution as a reagent. Once we add this to the organic sample, primary alcohols would be oxidized to carboxylic acids, whereas the secondary alcohols would be oxidized to ketones. However, if there is any tertiary alcohol in the sample, it will not be oxidized. This can help you differentiate or distinguish between primary and secondary alcohols and tertiary alcohols. From the concept explanation, what it simply means is that when we oxidize an alcohol, we are saying that the carbon that has the hydroxyl group would lose the hydrogen. In terms of the color change, we are saying that the orange color of the chromic acid would change to a blue-green solution. Here, the blue-green will tell us that the sample contains either a primary alcohol or a secondary alcohol. I hope you get the concept. Now, the procedure for undergoing this test is explained as follows. You place your sample that is to be tested in selected dry test tube. For your sample, you can place them in the test tube through 5 drops or measure 1 ml of the sample. When you are done, you add about 10 drops of acetone and 2 drops of acidified chromic acid. Wait and observe carefully whether there will be any color change. When you have your brown red color of the chromic acid changing to the blue-green color, then we are saying that there is a positive test. Positive test here meaning that there is a presence of primary and secondary alcohols. This is a chemical equation that represents the chromic acid test. As explained in the concept, the carbon that is bonded by the OH functional group, so in this case, this is the carbon, would lose the hydrogen, as it has already been explained. Let's look at the second example. This hydrogen would be lost. So when you compare the reactant and the product side, this carboxylic acid that has been formed as a result of oxidization has lost this hydrogen. The second equation too, the hydrogen has been lost, then your ketones are formed. Remember that there has to be blue-green color change to confirm that there is a positive test. Now, what did we say about the tertiary alcohols? We said that there would be no reaction. Why would there be no reaction? Because there wouldn't be any hydrogen there to be lost. No hydrogen here to be lost. Very good. Now let us look at another test that would help us to distinguish or identify aliphatic alcohols. This test is called the Lucas test. Now, this test is able to help you distinguish between primary, secondary, and tertiary alcohols that are water soluble. The Lucas reagent comprises of zinc chloride in concentrated HCl. It is expected that when you have this reagent and you add it to a sample that contains a tertiary alcohol, it should be able to give you an insoluble white layer or PPT. In undergoing this test, what you need to do is to get your test tube that is dry and devoid of any contamination. Then you put your sample in the test tube in liquid form. You add about 5 drops of your sample. You then measure 1 ml of your Lucas reagent, that is the zinc chloride in concentrated HCl. Then you add it to your sample. You cook it and then you mix it well for a few seconds. After you have mixed it through shaking, you may now take off your cork and then allow your sample or the mixture to stand for a few minutes, in this case 5 minutes. Observe closely if you would be able to see any form of cloudiness that it may or is likely to develop during this time period. We are advising that after 10 minutes and there is no sign of cloudiness, you may want to warm the test tube for about 15 minutes. This is done in a water bath. You would then record whatever you see in your data table that you have prepared nicely. In this chemical equation that involves the Lucas test, we have already said that tertiary alcohols would react rapidly. For secondary alcohol, the reaction is very slow. After you've heated it for 10 minutes, you should see a white layer. This is the equation representing that for secondary alcohol test. Primary alcohol, however, do not react. In other words, there is likely going to be no reaction. Now let us look at how we can test for aromatic alcohols, phenols. In the introduction, we said that there are 2 types of tests that we can do for aromatic alcohols. The 2 tests are ferric chloride test and the bromine water test. In the first one, which we are going to look at, which is the ferric chloride test, in terms of color change or appearance, we are saying that the sample that contains the phenol would react with the ferric chloride to give you either a green, blue, or purple complex ions. Let us look at this short procedure. With your sample, you place it in a clean, dry test tube, after which you add about 2 to 3 drops of your iron 3 chloride, that is the 2% aqueous solution of iron 3 chloride. What is expected to be seen? we are saying that you would have your orange yellow color changing to blue or purple. This would indicate a positive color test. This is the chemical equation for the test. We have our functional group here. Let us compare it with the product here. What are you seeing in terms of change? You realize that the hydrogen have been replaced by the ion 2 chloride. The next experiment for which we can use to test for aromatic alcohols is the bromine water test. In this instance, from your theory that you have done for this course, you'd realize that phenols are very reactive when it comes into contact with bromine. This is through the electrophilic aromatic substitution. Let us look at this equation here. With our functional group attached to the benzene ring, you would have auto and para positions occupied by the bromine. Then we are saying you would have polybrominated compound. Bromine here and another bromine occupying these positions. Let us look at the procedure. You would have to dissolve about 50 milligrams of the sample that contains the phenol. You would add 10 drops of methanol and some drops of water. Now, you swirl this mixture for it to dissolve, after which you would add your 15 drops of bromine water solution. After you have added your bromine water, swirl again and you continue to add your water solution, which is the bromine water solution, until you achieve a reddish color that would be consistent. This should indicate a positive test. Once you have the positive test, then you know that there is the presence of aromatic alcohol or phenol present in your sample. Now let us test our concept understanding with these post-lab questions. Number 1. In an unknown alcohol or phenol dissolves in water and in sodium hydroxide, would that compound be a phenol? Please explain your answer. The second question says that an unknown compound, B, is not soluble in water, nor 10% sodium hydroxide, but rather soluble in cold concentrated H2SO4. When such a compound is reacted with a solution of ferric chloride, the resultant solution remains yellow. No reaction occurs with chromic acid either. Identify all the functional groups that are present in the unknown compound B. I hope you do and did enjoy this short lesson. I've added the videos to your PowerPoint presentation and hope it helps you to understand the practical aspect much better. Thank you for joining our class today and see you next time.